Hello everybody, this is Master here, and today we're going to be coming over Redstone. As you can kind of see here, Redstone looks like this. I am using a texture pack, so it's not going to look exactly like this, but this is what Redstone looks by itself. Find Redstone from Redstone ores down in the caves from, I believe, ore level 20 or y equals 27 all the way to y equals 1. When broken, it will drop 3 to 5 pieces of redstone dust. Obviously, using a I cannot think of it. Using a fortune pickaxe will allow you to get more, and you need at least an iron or higher pickaxe in order to mine it. Now, redstone acts kind of as the wires of Minecraft and can travel a total of 15 blocks when powered. It can be powered by many different sources. For this video, I'm mainly going to be using levers and redstone torches, but can also be powered by a redstone comparator with something that has an inventory or interaction, observers, daylight sensors, buttons, and pressure plates, and also sometimes trap chests and also tripwire hooks. These are all ones that can output a redstone signal. What can also output a redstone signal are detector rails with a minecart of some sort over it. So as you can see, when powered, redstone will actually turn on. And they do believe, hold on, set light. Even though they may be turned on, they do not produce any light. Now as you can see, what I said about it being 15 blocks is true. And it will be not from the source, but from the starting of the chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At 16, it is not turned on. As you can see, there are no particles appearing near it. So if I were to move this redstone lamp one block closer, the redstone lamp would now be powered on. Move it one block back, it will not. Also, you have to look in the direction in which it is going. Even though this piece of redstone is on, this lamp is turned off because it is not connected to the redstone wire as is shown. It is just off to the side. Even if I were to do something like this, I'd have to have a piece going into it in order to turn it on. Now you might be wondering, if I can only go 15 blocks, well, how else am I going to make bigger machines than just 15 by 15 machines? Well, this is where a repeater will come in use. A repeater's function, or one of its two main functions, is to extend the length of a current. When any signal comes in from the back, it will produce a signal from the front back at 15, no matter what signal came in. If it was 15, as is shown here, or if it's anywhere lesser than that. But if an input of 0 comes into it, it will not produce any output. The second use can be shown by these two torches, and this use is as a timer. Well, more as a delay. You can right click to move the torches back. Each sort of tick will be one redstone tick delay. Naturally, repeaters will have a 0.1 tick delay. It can be set to a max of 0.4 tick delay. One redstone tick is 1/10 of a second, so when I power it, it would take 0.4 seconds for the lamp to turn on. And you can chain multiple ones of these in a row in order to achieve a bigger time. Now, interesting thing with repeaters is they can be locked, either on or off. If you have another repeater going into the side, or pointing towards the side of a repeater, and it is on, it will lock the repeater where it is. The time can still be changed on it, but because this repeater is on, if I were to turn it off, it will remain on for as long as it is powered from the side. Same thing if I lock it when it's off. Even if I have this on, this will remain off. Now, the last thing of main use are comparators, and these have two functions and can be shown by the torch in front. The first function is subtraction. Let's say I was to have a signal of 10. Then there is a signal of 14 coming in. If I was to power both of these, it will still power on. And I'll actually do the... Sorry. This is comparison. I'm sorry. It starts out with comparison. What it will do is it will take the inputs from all non-output sides, which are both sides and the back, and compare the greatest one. And then we'll produce that output. For example, this is output or input 14, this is input 10. Because it's in comparison mode and 14 is greater than 10, it will output 14. Now if I were to change this, you will notice that the output gets weaker. This is subtraction mode. What it will do is it will take all inputs and subtract them. And it will have it be an absolute value, as we cannot have negative integer values for Redstone. So since we have a power of 14 coming in and a power of 10, 14 minus 10 will equal a power of 4. So I can bring this out 4 more blocks, or sorry, 3, and then we'll die. It does kind of consume one output in order to do this. Now, the last thing is a redstone torch. It does provide a bit of its own light. Let me just turn this off. But not a considerable amount. It is in fact not enough in order to prevent spawning. But it does power redstone things on all sides. But will not power anything directly under it. But if the thing directly under it were to become powered, or the thing attached to it were to become powered, the redstone torch can be turned off. Now using all the things I've shown you, we can make gates and clocks out of this. This one is kind of a simple one. This just reverses input. So now this is on, the lamp is off. Now if I return to off, the lamp is on. This is used by just having a redstone torch on the back of a solid block. Now note, not all blocks will work. For example, transparent blocks, pane blocks, ladder blocks, and a few amount of transparent or semi-transparent blocks will not work with this rule. But any solid blocks like stone, wood, dirt, gravel, ores, even wool will count as solid blocks. The next gate is an OR gate. This one reads if either one is turned on, then the output is on. It doesn't matter which. Even if both is on, the output will still be on. The next one, next one is the exact same. I just reversed it so that way you can kind of see what it means. So this one requires both to be off. And this one's actually a XOR gate, I believe. Either XOR or NOR. This requires both to be on. Both to be on for it to be off. And either to be off for it to be on. So this one is an AND gate. Even if I was to power one of whichever side, the output is still going to be off. But if I was to power both, the output is on. So now that I got this fully right in my head, this would be the example of a NOT gate. These would be examples of OR gates, just in different configurations. And this would be an example of an AND gate. And the next thing are clocks. Now, a clock can be simply defined as a repeated timing mechanism. So this is actually a very simple one and a decently fast one. All we need to do is just give an input signal. As you can see, an input signal will kind of rotate around sort of in a clock fashion. Now if I was to attach a redstone output to this, you'd see the light will turn on and off. And you can make these as big as you want. As you can see, we got a really big one here. The bigger they are, generally, the slower the clock is going to be, or the longer it's going to take for this to turn on and off. Now, I have all these set to max, but if I were to go and set all these to the earliest time, this can also considerably fasten up the clock. Now, redstone lamps, they do have a slight delay on turning on and off, which is why this seems to be always on, as the time in between is very short. Now, with using a comparator, you can make a really fast clock. So fast that the redstone lamp doesn't have any time to activate. So instead of a redstone lamp, I'm going to use a dispenser filled with just a whole bunch of objects. Let's say 3 stacks of more dispensers. Using the subtract function from it, this is going to make a very fast clock, as you can see. And here's some explanation on how it works. So right here, we're always having an input of 15, which will make this the input of 14. As when it's in subtraction mode, it considers all current inputs. This input is 0 at the current time of turning it on, and this is always going to be 0 as there's no input here. So it produces an input of 14, which will power the dispenser, but will also feed back into itself. And that is the first redstone tick. Now we go to the second. It compares both of them. And because it can now subtract 14, 13, 12, it now will produce an output of 1, which will only go to here, which is not enough to power the dispenser, but also not enough to power back to itself. So we go to the third redstone tick, and we'll see there is no other subtraction for the 14, so we'll produce 14. And it kind of continuously does that, which is why we can have fast acting dispensing. Now you can also use a combination with redstone torches, a clock. Now, I believe it works. No, not like so. Okay, I gotta remember how to do these. These are a bit difficult, but I do know you can use redstone torches and redstone in order to make a clock. I just am not that experienced on here. Anyways, this is going to be it that I'm going to have in a video. If anybody would like to correct me or add on any things, please go ahead and do so. I would like to learn more and more about redstone. The next thing I'm going to get into are kind of these piston doors that you see in the background, and I may delve into command blocks for people who need help on that. Anyways, thank you all so much for watching. Like if you liked the video, and I'll see you in the next video. Goodbye.